Do you know your medicine?
Weed Maps and SC Laboratories bring you an educational series on the science of clean and safe cannabis. Today's cannabinoid profile is on Cannabigerol.
Cannabigerol, or CBG, is a cannabinoid that's found in the cannabis plant that is actually what we call the precursor to THC and CBD. So it's the first compound that's made. There's an enzymatic reaction which then leads it to be made to change into THC or to change into CBD.
Sort of the stem cell, you'd say, of all the other cannabinoids found in the plant. It can form THC, it can form CBC, it can form CBD, and even some other minor cannabinoids. It's never really found in very high amounts in plants because as soon as it's created, it's sent along a chemical pathway to form another one of these cannabinoids. But in its isolated form, it definitely has a lot of medical potential. It's a very, very strong anti-inflammatory.
It inhibits GABA uptake, and so GABA is a neurotransmitter in your brain, and when GABA is inhibited, you actually have muscle relaxation, and you have anti-anxiety effects. So it appears to promote similar effects that CBD has. It also appears to have antidepressant properties, and it also appears to have some modest antifungal properties. A lot is not known about the medicinal properties of CBG as it occurs in very small amounts and usually is not isolated out to be tested on its own. But it appears that it works in conjunction with the other cannabinoids to give that overall synergistic effect that people get with medical marijuana use.
Here we have the synthetic pathway for CBGA. You start out with gyryl pyrophosphate and olivetolic acid, and those two join together to form cannabigerolic acid. And here's the structure of cannabigerolic acid. We see the COOH, which makes it the acid. If that were to disappear, then it would just be plain CBG. And we can see this long chain of carbon molecules, which is able to roll up in different ways and roll upon itself and form rings and other structures, which lead to CBDA, THCA, and CBCA. So when we have undifferentiated CBGA, what enables this molecule right here to become CBD or THC or CBC are enzymes. And enzymes are sort of helpers to help catalyze these different reactions that have to occur in plants and animals. Normally chemical reactions occur under extreme conditions. Lots of heat, very acidic conditions, very basic conditions. But in the body we have these enzymes which sort of grab the molecule, in this case CBGA, and kind of form it into the new molecule and make that energy that it takes to form the next molecule much lower than if it were just by itself. So the enzymes become the limiting factor or the decision maker in what is formed next. If the plant makes a lot of THCA synthase, then we're going to get a lot of THC. If the plant decides to make a lot of CBD synthase, we're going to get a lot of CBD. So the way we can play around with the different levels of cannabinoids is by altering the amounts of these different enzymes in the plant. That can occur through breeding, it can occur through genetic manipulation, whatever it may be. With the legal restrictions placed on cannabis and other restrictions, there hasn't been a lot of real good research done on CBG and these other minor cannabinoids. Hopefully with the work SC Labs is doing, we'll see more breeders and more cannabis patients and more researchers all take note that there's more in cannabis than just THC, and some of these other compounds are very, very interesting compounds. They're all bioactive, so hopefully we can help spur some of that knowledge and to really finish some of this research that needs to be done and unlock some of the mysteries of these minor cannabinoids.